Hello! So, in this video, we're finally going to start doing some truth table problems. Very exciting. So, I'd like you to follow along with me, and I'd like you to do, in doing that, I'd like you to do two things. First of all, this is a PDF from a printout of one of the slides from one of the earlier presentations, videos, and it's called Tables for Negation Conjunction, and you'll find it in the module. So I'd like you to download this and have it open. And you're going to want to have this available while you're working on your own truth table problems. You can print it out, you could make a hand copy yourself, or just download the document. But one way or another, you want to have this file. It's going to help you to do the problems, and I'm going to be using it as we go along. And then I'd also like you to open up the logic program and open up the truth table module and find truth table 2.6 LRS 29 and follow along with me as I do it. So actually do the problem as I'm doing it. It's in that problem list. You'll have it there. You can see it. And if you follow along as I'm doing it, I think you're going to pick this up. That's really going to help you to pick it up quickly. Okay, so let's get started. So we have this truth table 2.6 LRS 29. Actually, why don't you pause and open and do all that, and then we'll get started. So we have this problem, 2.6 LRS 29, and this is negation of this thing, which is z and negation z. So this is just the same formula we've looked at both in English and in the logical language, although this time we're using z instead of p. So the question we're asked is this formula a tautology? So we want to know, is it true in every situation or not? And we thought that yes, it was. And now we're going to do that using a truth table. And here is the truth table. So Z here, that's the atomic, that's the one sentence letter that occurs in our formula. And then form, that's short for formula, this one, the one we're looking at. So what this is asking is, in the situation where Z is true, is the formula true? In the situation where Z is false, is the formula true? So let's start here. So we click on this question mark, and here we see the tree, right? This is the grammatical tree for the formula. We start with negation Z and not Z, so we remove the main operator, and we have just the conjunction Z and negation Z. We remove this main operator, and we have then its two pieces, Z and negation Z. This is a sentence letter, so we're down to sentence parts. This is a negation, so we remove the negation, we get down to Z. So this is the grammar tree, the parsing tree for this sentence. So what we want to do now is, as I showed in the previous module or in the previous video, we want to have these push these truth values up the tree to figure out what the truth value at the very top is. And so we're on the first row where Z is T, and that's what this shows here. So here we have Z and a T beneath it, we have Z and a T beneath it. So that's saying Z is true. Okay, so if Z is true, as we're assuming it is right now, then what's negation Z? Well, if we look over here, we see here's not negation box and here's box. So if box is true, then negation box is false. So in this case, box is Z, and then so we then have negation Z. So when Z is true, negation Z is false. So we'll click on this question mark and we'll choose F. If we'd chosen T, we would have gotten a very convenient error message, but we'll choose F. Okay, so now we have T and F. So we want to figure out, we want to continue up the tree, so now we look at Z and negation Z. We want to ask, is that true or false? So what we know is that the left conjunct is Z is true, and the right conjunct negation Z is false. So this is really true and false. Okay, so we'll come over here, and we want to find the column on the left-hand side where we have true and then false. So true, true, no. True, false, yes. So this is the row. This row of the truth table tells us how the conjunction is going to work in the particular situation we are in our tree. We have a conjunction whose left conjunct is true and whose right conjunct is false. And here we have left conjunct, right conjunct. So when the left conjunct is true and the right conjunct is false, then the conjunction is false. Okay, whenever a conjunction has at least one false, for the conjunction to be true, both conjuncts have to be true. If either one or both is false, then the conjunction is false. So Z and negation Z, that's false because negation Z is false. So we'll say that's false. Okay, so we've decided if Z is true, then negation Z is false. And so we have a conjunction of true and false, and a conjunction of true and false is false. But we're not at the top yet. We need to get to there. So, okay, z and not z. If z and not z is false, then what is negation z and not z? Well, negation reverses truth values, right? So if we are looking at negation box and box is false, then we see negation box is true, and that's the situation we're in. In this case, box is z and not z. That's what's being negated, and when that's false, then the negation is true. So negation of z and not z is true. So we click OK, and now this true is filled in. So what that's telling us is when z is true, this whole formula is true. So now let's see what happens when z is false. So when z is false, we'll click here. Okay. So, well, when z is false, then negation z is what? Well, if we're looking at negation z, so we're negation box. So when box is false, the negation is true. So we'll say that this is true. So now we're looking at a conjunction of false with true. Z is false, negation z is true. So it's false, true. So we have the conjunction here, box and circle. So our box is z, and our circle is not z, and we're looking at the situation where the box is false and the circle is true. So that's this row. Box is false, circle is true, so box is false and circle is true. Then the conjunction of those two is false, which is what it should be. When the conjunction has a false conjunct, then the conjunction is false. Okay? So now we have to take our last step. We have to go from z and not z to negation of z and not z. So when z and not z is false, what do you think the truth value here is? Well, this is the negation of this, so it should flip, right? So if this is false, then the negation is true. So again, we say true. And okay, if we had made a mistake, we would have gotten an error message, and we didn't, so we know this is correct. So we've done the problem correctly so far. Okay, so we're looking at this on the first row where z is true. We've decided the formula is true. But also on the row, on the situation where z is false, we've decided the formula is false. And so the formula is true. So if z is true, the formula is true. If z is false, the formula is true. So no matter what, the formula is true. And that means that this is a tautology. So okay, if we just click check right now, we're told that the problem is incomplete. You must answer yes or no to the question. So this tells us, this is enough information to decide that the formula is a tautology, but we have to click here and say, yes, it is. If we chose a no and said it was not a tautology, then the argument, it shouldn't say incomplete, it's saying, let's just, yeah. So, actually that's kind of confusing. We'll see how the not a tautology works. If you don't choose no there, if you don't choose yes, it's not going to work, but if we choose yes, then it's correct. So we've concluded that yes, it is a tautology. It's true both when this formula is, why can't I select it? It's true when z is true, and it's true when z is false. So that's an example. So in the next video, I will continue with some more examples. But what we've shown here is the formula is a tautology. How do we show that? So first we determine the formula's truth value on each of the rows, and they're just two rows, and it's true on both of them, and that means it's true in every situation, and that means it's a tautology. So to show that something's a tautology, we show true on all the rows, and then we click yes, and we check it, and it comes out correct. What we're going to see in the next video is some examples of sentences that are not tautologies.